Hello everyone. In this video today we want to talk about a couple of things. We want to talk about finding zeros of polynomials, which is what I have ready for us here for this first example. And then I want to talk to you a little bit about something called multiplicity. Okay, so let's begin with this first problem. Find the zeros of f of x equals x to the third minus x squared minus 6x. Okay, so we're thinking that we want to take our polynomial and set it equal to 0. All right, so how do we handle this? Great idea out there. We want to factor, if we can, our polynomial. So what I notice is that we have an x in common. So if we factor out an x from every term, okay, then we want to see if we can actually factor the trinomial, which for this example factors into x minus 3, x plus 2. Okay, and then we can take a look. We can say that x equals 0. We can say that x minus 3 equals 0. So you would just say x is 3. X plus 2 equals 0. So x could be negative 2. All right, so we could take a look at this. If we wanted to graph it, we could check that our zeros are correct. Just to verify our work. All right. So there's a nice little example. Some of you say sometimes you'd like to see a second example. So let's throw one in here. How about f of x equals, how about x to the third minus 4x? Okay. And the directions again say find the zeros. All right, so x to the third minus 4x equals 0. Okay, again, we have an x in common, so I'm going to factor that out. All right, so then you have to remember a special rule from your past, x squared minus 4. Okay, I'll put over here to the side. Maybe you remember a squared minus b squared. Someone somewhere may have said to you, hey, that's what we call a difference of squares, perfect squares, a squared, b squared. So how does that factor? Well, the rule is to do a plus b, a minus b, because we have no middle term, and that's what would happen if we were to FOIL the a plus b and the a minus b. Okay, so long story, but we would factor x squared minus 4 into x minus 2, x plus 2 equals 0. So we're finding here that x is 0, x is 2, or x is negative 2. And again, we could verify graphically if we wanted to. Okay, or plug your values back in and that would work out just fine as well. Okay, well, let's consider this another example involving zeros. Let's suppose I give you the reverse problem. Okay, so instead of you find the zeros, how about I give them to you? So maybe I say find the polynomial with zeros. How about at x equals 0, x equals 1, x equals negative 3. Okay, so in this case, you have to work the problem backwards. Okay, so your f of x would become, all right, well, if the 0 is 0, that's indicating just plain old x is a factor. Okay, if x equal 1 is a 0, then x minus 1 is going to be your factor. If x equals negative 3, then x plus 3 is going to be your factor. So then to find the polynomial, we want to simplify this. So I would probably multiply here the x and the x minus 1 first. So we would get x squared minus x. Then from there, let's go through FOIL between the x squared minus x and the x plus 3. Okay, so if we do our multiplication, we'd have x to the third plus 3x squared. Okay, and then we would have minus x squared and a minus 3x. Okay, and looking to simplify here in the center, we've got x to the third, like terms here, so a plus 2x squared and a minus 3x. Okay. So that would be the reverse question if we'd happen to run into that. All right, so continuing, the next topic in this particular section has to do with what's called multiplicity. Okay, so what we mean by multiplicity is that we could have a repeated zero, right? So for the definition, we could say something to this effect. If f is a polynomial function and x minus c to the m power is a factor of our f function, but x minus c to the m plus 1 is not, then c is a zero of multiplicity of f. Okay, so we could even paraphrase here a little bit. Zero of multiplicity when m is greater than or equal to 2 means or is a repeated zero. Okay, so how will we go about using this? And if you need to pause for a second, I get it. You have a lot of writing right there. All right, so here's the bottom line. The zero of odd and even multiplicity. All right, if x minus c to the m, okay, so if we have a factor, we have some exponent m up there at the top, and we observe that m is odd. All right, so what this is going to mean to us is that our graph crosses the x-axis, meaning that we're going to have a sign change happen, okay, at the 0 x equals c. Okay, so again, that's if m is odd. Okay, we're going to cross the x-axis. Second situation is if x minus c to the m, we observe m is even. Okay, so if m is even, our graph bounces, or I'll say sometimes it'll touch and run, whatever little catchy phrase we want here, to the x-axis, at x equals c. Okay, so that's going to happen if m is even. Okay, touch and run, or it bounces. Okay, I read one worksheet one day. It said, oh, it goes up, gives the x-axis a kiss, and runs the other way. It's like, well, I don't know that we really want to say that, but okay, that's what it does. Okay, so let's take a look here. Have a little example about multiplicity. Let's say that f of x, already factored nice and pretty here, x plus 2 to the third times the quantity x minus 1 squared. Okay. All right, so what do you know? What do we know? Well, we know there's some zeros. Okay, where would your zeros be? Okay, yes, you're right. It would be at x equals -2, x equals 1. Those are your two zeros. Okay, now, what about the multiplicity? The multiplicity of -2 is 3. Okay, that would be odd. So that means at at -2, okay, we're odd, so we will cross the x-axis. Okay, the 1 has a multiplicity of 2, which is an even number, which means it's going to touch, or if you like the word, it bounces. Okay, going to go up, hit the x-axis, come back, What else could you tell me here? You can tell me that the overall degree for our polynomial is 5, okay, which is odd. So we have an odd degree polynomial. Can you tell me anything about the leading term? The leading term. Well, you're going to have to think a little bit in here. If you were to actually think of foiling, it looks to me that you're going to have a positive leading term. Okay, so here's the kind of the gist of what we know. If we think of this graphically, over here at -2, we have a 0. At 1, we have a 0. Okay, so now this degree stuff and odd and leading term positive should make you think of a graph that looks something like this. Okay, so let's see if our rules of multiplicity fit this idea over here. All right, so we should start coming from -infinity up to the -2. According to what we've discovered, we should cross the -2. We're going to do some kind of action here in the middle. Come to the 1. We're supposed to bounce and go on the other direction. Okay? And that actually matches what we know for rules of multiplicity and also our in behavior as we even look at the leading term on this problem. Okay, I hear you. We'll do another one. All right, let's say, let's do this one. Let's say f of x equals x minus 2 to the 5th power times quantity 2x plus 5 to the 4th power. Okay, so let's see what we can figure out here. All right, we'll start with zeros. Okay, so I see first I have an x, or a 0 at x equals 2. We have a multiplicity of 5, correct? If you look at the next term, we have a 0 at -5 over 2. Multiplicity of 4. Okay. All right, so let's make a note to self here what this means. The multiplicity is odd. So if you're odd, you're going to cross the x-axis at that location. Multiplicity is even. That means we're going to bump or bounce or touch, whatever word we want, touches the x-axis and goes back up the other way. Touch or bounce, bump, whatever, no sign change is going to happen there. All right, let's see what else you know. The degree of this polynomial is going to be 9. It is odd, so we have an odd degree. What do you know about the leading term? Okay, if you look at the leading term, I'm kind of combining lots of ideas from the previous video with this one. Okay, leading term on this one. Okay, again, you're looking here, when you multiply things, it's going to be a positive. Okay, so we are positive, odd, so we know the general shape of our graph. All right, so now let's see if we can do an actual little sketch here, incorporating our zeros. Okay, so we have a 0 at 2. We have a 0 at -5 over 2, or -2.5 here. Bump this over here. -3, -2, -1. So right in here at -2.5. All right, so our odd positive looks like this. So we're going to again come from -infinity. We're going to cross. Oh, where are we? Whoops, we're not going to cross here, are we? Let's back that up. My bad, I had us backwards. We want this part right here. Okay, so what do I want to do here? I want to get rid of this. Goodbye. Let's try. Hey, that was fun. Want to try that again? Woo! Okay, -2, -3. We were right here at -2.5. Sorry about that, guys and gals. Okay, let's do this again. Okay, so we have a multiplicity that's even. We need to just touch at -2.5. Okay, so here we come. Woo! Up here, touch. Come down the other way. And now we have an odd, so we will cross. And that's something that our graph could look like. Okay, sorry for that little interruption there. Last thing to mention here is something called the intermediate value theorem. Intermediate value theorem. Okay, and in a brief way, we could just say it's like this. If f of a and f of b have opposite signs, then f of c equals 0 for some number c in the interval from a to b. So in other words, our graph needs to cross our x-axis. Okay, so let's suppose that, let's say A's over here and B's over here, and I have a point C somewhere in between them. Okay, so C is in that interval between A and B. Okay, we know that F is continuous. Okay, so that we're going to have some y naught value between f of a and f of b. Okay, so it's going to take off here, going to come up through here, whatever the graph is, it's going to pass through such that we have a 0 in between. Okay, so that the y value of c is 0. F of c is 0. Okay, so I think that if you have a sign change between f of a and f of b, it could just sort of make sense that c is in between. Okay, do I have anything else for you here? It looks like we've covered everything. And certainly if not, give me a shout. Let me know what I can do to help out. Okay, so again, the focus here, we had to talk about multiplicity. We had to talk about zeros of polynomials, finding zeros, okay, by factoring, whatever means we needed to. Okay, have a great day, everyone. Thanks for